you have to consider this particular carbon, and I am telling you this is the odd member ring because it contains the carbon atoms in odd number, that is 3, 5, 7, and this is odd member ring. And if we are going to consider the even membered ring, then that particular membered ring is generally contains the carbon atoms in 4, 6, 8, this particular even number rings. So now what I am telling you is, consider another examples, and after that example I am telling you a very important point. Consider this example: no plane of symmetry present, no center of symmetry present, and the compound is chiral. So this is the example of chiral compound. If I am saying you this is a particular carbon atom which is present in front of you, and these are the 2 hydrogen atoms, and this is a CH3 group, this no plane of symmetry, because if I am going to pass this particular plane, you are going to see CH3 which is reflected with this H hydrogen, and this is a hydrogen which is got reflected with the methyl groups. So hydrogen if reflecting with the CH3 group, this cannot possible. This cannot possible because hydrogen is reflected with CH3, and if hydrogen got reflected with CH3, then this will not result into the indistinguishable form. So that's why this is a chiral molecule, because there is no plane of symmetry present, no center of symmetry present, and the molecule is chiral. Consider this example. You can draw this example like this as well. Consider a CH3 molecule that is present on the top, and you can see there are 2 hydrogens, that is one hydrogen above the plane and one is below the plane. One hydrogen is above the plane and other is below the plane, and you are going to bisect your system from this side. This CH3 molecule, consider the methyl group as the spherical molecule. Consider the methyl group as the spherical molecule, and you are going to learn about that the plane of symmetry exists if you are going to bisect the CH3 molecule from the center along with this carbon atoms, just like this. You are going to bisect the molecule in this particular 2 halves, so that your 2 hydrogens from this side reflect from this side. These are the 2 hydrogens, and you are reflecting these hydrogens, and there is a CH3 group. There is a CH3 group, and this particular CH3 group is bisecting because you are considering the CH3 group as a spherical part. You are considering this spherical molecule as a spherical part, just like this, and you are bisecting your system like this. And if you are bisecting your system like this, then these CH3 molecules got bisected, not reflected. This CH3 molecule got bisected, not reflected. You have to mention this, it's bisected, not reflected, whereas these hydrogens got reflected. So that's why this particular molecule is achiral, because plane of symmetry exists in this particular molecule. This is a plane of symmetry exists in this molecule, so that's why this particular molecule is achiral. Always remember this thing and mention by in your heart, mention in your stereochemistry notes with the bold marker that never check center of symmetry in odd member ring. Always remember you have to check the center of symmetry in even member ring, but you not have to check the center of symmetry in odd members ring. This is a very important point that you have to mention, that in the odd member ring I am talking about 3 membered ring, 5 membered ring, 7 membered ring, 9 membered ring. I am talking in these rings. You don't have to check about the center of symmetry in odd membered ring. Now consider this example of even membered ring. This is the last example of this lecture, that is this particular example of cyclobutane. This is a cyclobutane, this is a substituted cyclobutane. This is the example of substituted cyclobutane, and in this particular example you have one plane of symmetry, that is this particular plane is present and no center of symmetry is present, because if you are going, just consider, is this particular center point, and if you are going this hydrogen and there is a methyl group, there is a methyl group and there is a hydrogen, so center of symmetry is not present in this particular molecule, but plane of symmetry is present, and hence our molecule is achiral, because plane of symmetry is present, center of symmetry is not present, but plane of symmetry is present. That's why our molecule is achiral. And there is a plane that is passing, and it's a reflecting plane. This is reflecting plane because no atom going to bisect when we are passing the reflecting plane. No atom is bisecting at this particular side, so that's why this is a reflecting plane of symmetry which is present in this cyclobutane, substituted cyclobutane, and our molecule is achiral. Now consider the last example, that is this particular example in which the 2 similar groups are attached but with different stereochemistry. So there is no plane of symmetry, no center of symmetry, hence the compound is optical active and chiral. This compound is chiral and optical active. Always remember one thing, that if the two substituents are attached to the adjacent carbon atoms in the same stereo, then the compound is achiral. How you are going to check this? If the compound with the same stereo, just consider there is an arbitrary group, any arbitrary group. Consider there is an arbitrary groups that are generally attached to the adjacent carbon atoms of the cyclobutane in the same stereo. Same stereo, same group if present, same stereo and same group on adjacent carbon atom if present, then the compound is achiral. You have to remember this because it makes your stereochemistry learning easier. I am saying if you have a same group in the same stereo attached to adjacent carbon, then you have to consider as an achiral, because always a plane of symmetry is passing. And if you have the same group in different stereo, you have same group in different stereo, then the compound is optically active, because there is this difference in the stereochemistry. So that's why the plane of symmetry doesn't exist and the center of symmetry doesn't exist, because if we are considering a sample, even in this particular compound CH3 got in 180-degree opposite direction, you are getting an hydrogen in terms of CH3. So that's why center of symmetry doesn't present. But if you have the same molecule with different stereochemistry, then you are definitely going to have the chiral compound, that is a optically active compound.